That was the subtitle. I couldn't get past legal on this talk, one man, one job. So here's all the stuff that we're going to go through in this talk. I won't go through that. I'll just get straight into it. Very quickly, background on me. I do security response for Red Hat's middleware division. So that's a whole bunch of products that run on top of Java, all of the JBoss products. Has anybody heard of JBoss? Bueller? Okay, yes, great. People have heard of JBoss. And we have a bunch of other middleware products that we've just acquired, FuseSource and Polymeter, that run on top of Java. So my job is to handle all of the security flaws that affect those products, to triage them, to ship patches, answer customer queries, and so on. So in doing this, it's a largely reactive role. And in doing this, I've started to realize that there's some sort of fundamental problems with handling security in Java applications as opposed to, say, in a Linux distribution, because that's the other thing that Red Hat does, is a big Linux distribution. So I see how those guys handle it, and I think their systems and tools and processes are way better than we have for Java. Why is that? And hence this talk. So here's the crux of the problem, is that in a Linux operating system, typically what you have is a package manager that provides a system-provided library for everything. So you have libpng, lib this, lib that, and you have one single copy of that which is provided by an RPM or a deb or whatever. And then all of the other RPMs or packages that depend on that library have a dependency on that, and they just dynamically link to the system-provided version of the library. So if you have a security flaw in that library, all you have to do is patch the library. Now, if anybody saw Silvio's talk the other day, there's some nuance to that where sometimes packages embed other packages, but they're doing it wrong. When you're doing it right and you have one single system-provided instance of a library, handling things from a security perspective is fairly straightforward. You patch that, you ship an updated RPM, job's done. But in the Java world, what happens is all of the applications bundle their own dependencies together. So this is applications in terms of, say, the JBoss application server, but also the applications that are deployed on it. All the J2EE apps, what they do is they have a lib directory and they include their own versions of everything. Now, sometimes there can be a system-provided version by the application server, but this isn't a standardized thing. Generally speaking, it's just like everything is statically compiled. It's like having a Linux system where every single binary is statically compiled against its libraries. So when we find there's a flaw in a particular library, where are all the places where that library is being used, and where do we need to ship the patch? The way that this is managed in the software projects is generally that there are dependencies handled by a tool like Maven, a build tool like Maven, and those dependencies will be brought in from a repository, either an internal repository or the canonical Maven central repository. Aspect Security did a study recently where what they did was somehow got all of the download logs from the Maven central repo, and they mapped those against the dates at which particular CVEs, particular flaws had become known public. And they found that 26% of all the downloads from the Maven central repo had known flaws in them at the time where they were downloaded. So not that the person downloaded it and then 3 months later they discovered this flaw, but there was a known and published flaw at the time when the download occurred. So why is that? Because there's no real mechanism for developers to know, oh, I need to include this new version of a library because the old version has a flaw. If they're not manually tracking all of the flaws across all the libraries, they'll just keep pulling in insecure versions from the Maven central repo. So what they recommend is interesting. The second point there, you should enforce scans of dependencies against a known vulnerability database. So I contacted them and I said, this is an awesome idea. Do you have a known vulnerability database? And they said, no. That's our recommendation, but nobody has one. So, interesting. And this, again, shout outs to Sonotype who worked with Aspect Security on this for this cool graphic. This just illustrates one example, this critical flaw. I don't know if Meta is in the crowd, I'm not sure. But this is one that he found in Spring, and it turns out that Spring's included in everything. Any app that uses Spring, is built on Spring, typically includes its own version of Spring. So these are just the open source packages. All of these open source packages had to be rebuilt and an update shipped because of the flaw in Spring. So this is a huge overhead for all of the vendors, not just Red Hat, but Oracle and everybody else having to handle this. And then from a developer's perspective, from the, I guess what I would consider the end user, the J2EE developer writing an app, how are they supposed to handle this? If they're building a Spring app, they've got something like that snippet over there in their Maven POM saying use this version. Now there's been an advisory saying you need to use sec01. How do they know that? They can track the upstream website, but how many upstream websites? They can subscribe to a commercial alert service and they need to somehow consume that information. And then if they manage to do that, they go to sec02. Now a new flaw comes out and you need sec03. So it's this very difficult management problem. So my focus is not so much on the end user applications, on the J2EE apps, but on the application server because I have to support that. So again, they have a similar problem to the end user apps though. The products bundle all of the dependent jars into a zip file. So we have this run anywhere zip, you can put it on any JVM, just unpack the zip and run it, but all of the libraries are bundled with it. So we can't rely on the system to provide a secure version of a particular library. We have to look across all of the instances where we're shipping that jar, and often there's multiple instances in one product, and ship updates for those. So this whole problem, I looked at it, analyzed the whole problem, and I came up with this basic solution. And the first thing we need to do is collate all of our builds so that we can have a manifest, recursively unpack them, and have a manifest saying, these are all of the jars that are included anywhere in our code. And then the second thing we need to be able to do is perform a check against the database of known vulnerable jars at build time, so that I can look at that database of known vulnerable jars and say, that affects these things that we're shipping, and at build time I can prevent people from including things that already have known flaws. So this is a better way of depicting all of that. Whenever there's a build or a release, we generate a manifest from it, and then whenever we get a vulnerability report coming in, we can look at the manifest and say, oh, in all of these places we have this vulnerability, let's file a bug. So this required 3 components which didn't exist yet. The first thing was the manifest generation tool, and this turned out to be pretty trivial. It downloads all of the zips, it recursively unpacks them, so you have a zip with a war, with an ear, with a jar, with an ear, with a war, and then you go to the root node and you get all the root node jar files out of it, and we just put this into an SQL database. The next thing is, this is the hardest one actually, is we need a, as we mentioned way back here, enforce scans of dependencies against a known vulnerability DB. So we need a canonical database of known vulnerable jars. And I'll get into the details of this in a minute, but it gets a little bit sticky about how you identify and match a known vulnerable jar. But the main thing is we're using SHA-1 or SHA-512 fingerprints, hashes of the jar to do that. And then the final thing is we have a Maven plugin, Enforce Victims Rules, which allows you to, according to configuration, at build time, either throw a warning or fail your build conditionally if known vulnerable dependencies are included. So I'll go through each of those 3 tools briefly in more detail. The JBoss manifest, like I said, is the simplest one. All it's doing is crawling those builds from our release sites and putting that into a manifest database. And like I said earlier, this needs to sort of recursively go inside all of the packages and look for the root jars. And inside of a jar, you have 2 things. You have class files, and then you have the metainf directory, metainf manifest.mf and other artifacts in there, which provide you with metadata about the jar. And that's critical. The stuff that's in manifest.mf allows you to do things like you get a version string, you get a title string, and there's also other manifest data in there about who signed the jar, if it's a signed jar, and you can get all this information out. The thing that's really tricky about this is that there is no published standard for manifest.mf. It's just a de facto standard, and people put whatever they want in there. There's no minimum set of required elements. You can't say every jar has to have a title and a version. You can leave out manifest.mf and it's still a valid jar. And different build tools and different systems put different stuff in there. So trying to identify a known vulnerable jar based on the manifest metadata is impossible. Well, it's not impossible, but it's always going to have false positives in there because people can include whatever they want. The way that we run the JBoss manifest tool, it's actually a Jenkins job that's scheduled every 10 minutes. It looks at the ftp.redhat.com and other places where we publish the software looking for a new version, and it sends emails to the security response team when new packages are found, so we can identify everything that's being, all the new software that's going out, and it automatically adds it to the database. So there we have a canonical manifest of what we ship and what we support. The next step is the known bad jar database. So it turns out that somebody else in the company had already done this like a year ago or 2 years ago, but it was abandonware. He'd identified the same problem, and he'd done a sort of proof of concept run and taken 50 popular jars and hashed them all and put them all in there, and then promptly forgotten about it. So we resurrected this effort, and it's up there now. It's just a simple database. It has a REST interface, and you can get a local copy, and it's just a database. But the important thing is that we've embedded it into our vulnerability response workflow, that we maintain hashes for all flaws that affect the components that we ship. And we maintain different hashes because there will be the hashes for the builds that are in the Maven central repo, and then there will be also hashes for the builds that we ship in our products, which are typically not taken from Maven central repo. We rebuild ourselves, and because we rebuild, it's got a different hash. So we keep hashes of all these different instances, and as new flaws come out that affect anything within our products, we'll put an updated hash into the database. So there's now quite a usable set of data in that database. But really, it needs more community effort because there's a whole bunch of different Java components that we don't ship, so we're not maintaining hashes for them. If anybody could do one thing to help with this effort, it would be start to contribute some hashes of known bad jars for things that you maintain or handle. And then the final step is the Maven Enforcer plugin, which, like I said, it just goes to a web service and looks for the database, looks for the canonical copy of the victim's database, and then at build time, checks to see whether you're including any known vulnerable dependencies. Now, those checks are done in two ways. If we use metadata, i.e. the stuff that's in manifest.mf, then we've got a lot of scope for false positives, because somebody could say they could have a version of Spring 2.5.6 that actually has all the security patches applied to it, but they never updated the manifest. So it still calls itself 2.5.6 rather than 2.5.6.sec03. Or they could have one where it's also false negatives, because they could have one where they just don't include that manifest data, and even though they're vulnerable, we can't match it. So we could do a match there, but it's quite, it has a poor hit rate. The other way of doing it is based on the file hashes, and this is guaranteed to have 0 false positives, because if it's a known bad jar, it's a known bad jar. But it has a lot of scope for false negatives, because if somebody rebuilds their own version of a jar, and therefore it's got a different hash to the ones that we've identified, we won't catch it. So typically what we do is have both of them in there, and if there's a metadata match, you get a warning, and if there's a hash match, then you get a fatal error and it fails the build. And that seems to provide a good balance. So I'm pretty sure that's not legible, but basically, sorry. That's just how you set it up in Maven. You just declare it and blah, blah, blah. And then this is what it looks like. At build time, it identifies that you've got a vulnerable artifact and throws you this warning. Well, in this case, it's giving you a fatal error. You can see that it's matched based on hash. Those are the CVEs that match that hash, and then the build fails at the bottom. I was going to do a live demonstration of that, but that's really dangerous, so I'm not. This is where it gets interesting. there's a bunch of commercial tools that, that have just recently come out in this space. And this is very new. The first one is Sonotype's Insight App Health Check. And I think this tool has been around for a while, but they are actually providing you with the ability as a developer to identify known vulnerable components that you're including as a dependency in your Maven POM. So what happens is you either use their GUI and you click and choose and here's my build artifacts, or you declare it as a Maven plugin, similar to what we're doing here. Actually, I think I will give the live demo, sorry, because it's relevant to this. Just 1 second. Okay. So here we have a sample little project. And if we have a look in the POM file, you can see that we're declaring a dependency on the enforce victims rule. And then as a plugin, we declare it. And we provide these different options. So we say for a metadata match, which is where it's based on the manifest.mf data, we throw a warning. But for a, whatever it is, for a fingerprint match, a hash match, then we give a fatal error. Now, I don't think this is, the reason I didn't want to do it, I don't think it's going to work because I don't have internet at the moment. And it's not going to be able to sync the database, but I'm not sure if that's going to fail cleanly or not, because it's got a local copy of the database. There you go, it does work. So you can see there that it shows you the enforce victims rule settings, and then it identifies oh no, it's failed because it's unable to synchronize. Yeah, sorry, because I don't have internet. But you can see how it's going to work. And the Sonotype one works exactly the same way. You just declare stuff in the POM and you say, I want to use this Sonotype service. But the way that it works, the way that Victims Enforcer plugin works, is it's just pulling a copy of the database over the net. And I could have made a local cache and made that work. But the way that Sonotype's one works is the whole thing is a remote service. And all it does is send information about your build and your build artifacts off to their remote web service. Magic happens, and then you get back a report. So we have no idea how they're actually doing this. We don't know what sort of database they've got of vulnerable jars. We don't know how they're matching them, whether it's based on hashes, metadata, or combination, or something else, because it's all just magic that's done by this web service. So I guess my FUD pitch would be, you don't know what it's doing. It just comes back and says, oh, you've got vulnerable dependencies, but there's no insight into how it's actually working. And you pay, I think it's $4.99 per app for that. The other one that's come out is Aspect Security's Contrast tool, and that only came out in the last couple of weeks. This one doesn't actually identify known vulnerable jars in your dependencies, but it's similarly, it's a Maven plugin, and instead it's doing, I think it's dynamic analysis rather than static analysis, but it's doing some analysis of your code at build time to identify common categories of flaws. So it reflects through the code and it says, you know, this looks like SQL injection, this looks like cross-site scripting, and gives you a report, and I think it will conditionally fail builds. But it does all that locally, rather than relying on a web service to do it. So interestingly, we put this out after we had produced all these tools, because this stuff has all been released as open source. The victims database, the plugin, it's all up there. And we put some messages out to mailing lists saying, hey, we've produced this stuff, is anybody interested in using this stuff? And that's how I found out about these tools, because they contacted us and said, well, contacted the public mailing list thread and said, we're really interested in this. And in particular, I think the contrast tool wants to have this kind of database so that they can add it to their to their offering. Rather than just identifying flaws in your code, it can identify vulnerable dependencies. So everything, like I said, everything is up there. If you are a developer of a J2EE app or a developer of anything that runs on Java, all you need to do is go and get that victims enforce plugin and drop it into your Maven POM, and you can start using this stuff now. If you're maintaining if you handle security response for any Java components, or you're even reporting flaws against Java components, you can go to victims, vitci.ms, and you can add hashes. You can add them anonymously, and we'll just review them before we commit them to the database. That anybody can submit hashes. So please do, because the more that we get, the better this tool will become. And I would really like it to be a shared effort. I don't care if people use it for commercial tools. They can do whatever they like. I just want there to exist a good canonical database of known vulnerable jars. So that was the material that I had. Any questions or input on that from anybody?
Questions? Pretty cool talk. First of all, did you try to compare to the Sonar type database, like submit a vulnerable project to the database and see what their report is?
I'm not allowed to buy commercial software, so I couldn't do that. I couldn't test it, but I would like to do that. Yes, I would like to do that comparison.
Sorry, a question here. Have you actually thought about writing an RFC or maybe contacting people who actually build those jars to include in the manifest file, say, the CPE string, to make it easier and make some sort of standardized way of doing that so that people could adopt that?
Something that I'm trying to work on via the JSR and the Java community process to try and get that formalized. But I know that that's the kind of thing where I'll get it formalized in time for Java 9, and then they'll start using it in 2015, and you know what I mean? So I am trying to do that through the JSR, but I know that in the midterm, I've got to deal with the lack of standardization. Yeah.
Any more questions? I have one actually.
Sure.
So for victim.ms, victi.ms, how do you verify that when people upload hashes of known vulnerable packages, how do you verify that they're actually vulnerable?
Well, the first thing you do is, if there's a reproducer available, then use the reproducer. Or the other thing would be, if, say, for example, there was, like going back to the example that we had at the start, where the vendor says 2.5.6 is vulnerable, and if they then linked me to, they gave you a hash of the Maven central repo build of 2.5.6, and the vendor says 2.5.6 is vulnerable, it would be pretty sane to say this is a known bad hash. So you'd use either of those verification mechanisms.
So you have to give them some kind of reference so that they can verify against the hash that it is actually bad. Okay.
Yeah. Yeah, because that's something that somebody brought up. They said, oh, what I need to do is denial of service you by flooding you with bad hashes. So you spend all of your time filtering out all of the bad hashes that I submit. And then you can't keep the database updated. But don't get any ideas.
Well, I was thinking if you submitted Maven as an actual bad as actually a bad application, and then it tried to verify itself.
Well, I think it would get pretty quickly caught because we'd start using it. So that's the other thing that didn't make it onto these slides. Unfortunately, this is all really recent that this stuff has been done. And what we're now doing is actually incorporating the plugin, the Enforcer plugin, into our internal build system. So my initial focus was just to build this infrastructure and to try and push it out there for J2EE developers to use. But now we're putting it into our internal build infrastructure so that all of the builds of the JBoss products will be run through the plugin. Rather than, because we have a central build system, brew and mead, so rather than relying on the individual developers and committers to use it, if we just put it into brew and mead, then their builds will fail, the continuous integration will fail after their commits if they include a vulnerable dependency.
All right, very cool. Any more questions? Or, one.
It strikes me you've got a problem there between exact matches with the hash and the metadata probably throwing up too many possible non-fatal warnings.
Well, both false positives and false negatives for the hashes, for the metadata, yeah.
Right. In Silvio's work on vulnerability, he looked at locally sensitive hashes that will catch near misses and near duplicates.
Yes.
Have you considered putting something like that in your database? And you obviously couldn't do fatal crashes, but you could do warnings on things like this.
This is something I've been talking to Silvio about using SimSeer, probably not clone-wise so much, but SimSeer to take the similarity between the two jars. And you could say this jar is 99% similar to that jar. The problem with that is a lot of these, the only difference between the vulnerable jar and the fixed jar is that they've just applied the isolated security patch. So the fixed jar would be 99% the same as the vulnerable jar. Whereas when you have something like a component upgrade, you say there's a flaw in CXF 2.4.8 and it's fixed in 2.4.9, then you're going to have like 10% delta in there, and you could, you know, it would be easier to identify. But for ones where you're dealing with isolated security patches, it's going to be impossible based on just internal similarity to say this looks like the vulnerable version.
You need more smarts.
You need, yeah, and so it's an open research question. We put this out there as a kind of proof of concept and said, here's something that you can do, and the hashes are good because, like I said, they have a 0 false positive rate. We know that if you catch a hash, it's a problem, but we also know that it's going to miss things. If you're using a build that's not in Maven Central Repo and it's got a differing hash, then we're not going to catch it, and we know that's a problem. So the metadata is a potential solution to that, but not yet. So yeah, I'm very open to ideas and development on this.
I'll talk to you offline because I'm actually talking about the same issue to Silvio.
Okay, great.
Any more questions? All right, well, let's thank David once again. That was very good.
Thank you, everybody.